All right, so we're going to look at collecting like terms. So this is sort of introduction to algebra topic, and we're going to see how we can take some terms, which is something separated by a plus or a minus, and then bring them together if possible. It'll make sense as we go through. So Violet Beauregard is visiting the chocolate factory. Willy Wonka gives Violet a bag with an unknown number of lollies in it. He also hands her 4 extra spare lollies. Draw a picture to represent the number of lollies that Violet has below. Well, we don't know, how many lollies are in the bag. So if we draw a bag, and this is going to be terrible, we can say this is our bag of lollies, and it's got lollies in it, and they got 4 extra spare ones, right? There's one, two. Oh, went the wrong way. 3 and 4. You get the idea. So it looks something like this. So yeah, that's a picture that could represent the number of volleys she has. So that's the first part. Write an algebraic expression to represent this situation. Define the unknown that you use. Okay, so we don't know the number of volleys in the bag, so now we have to write an algebraic expression. So what we're going to do is going to say, all right, the number of lollies in the bag, let's call that x. We do know that she gets 4 extra lollies. So it has something like this. Okay, visit this link and create the algebraic expression using algebra tiles. Draw the algebra tiles below. So algebra tiles are a great way to visualize algebraic expressions. So this is how you use it. First thing you want to do is you want to click up here on 2 variables. So it gives you all the different algebra tiles, x and y. Okay, so our situation, Violet, she has a bag, which you're going to represent with this x, this unknown x. A bag of lollies with some unknown amount in it. And then she's got 4 extra lollies. 1, 2, 3, 4. So something like that. This algebra tiles here would represent x plus 4. So that's what we need to do. We need to draw that down here. So x tile, and then we've got 4 spare ones. So it looks something like that. All right, Violet opens the bag and realizes there's 15 lollies in the bag. How many lollies does Violet have in total? Okay. Well, we now know that x is 15, so we know that it's going to be 15 plus 4, which is just 19. Okay, so she's got 19 lollies in total. So x went from being unknown, and then we said, all right, now x is 15. So we made a substitution into here. Okay, part 2. Wonka gives Augustus Gloop 3 bags of lollies and 2 extra spare lollies. Write an expression to represent the number of lollies Augustus has. Define the unknown that you use. Okay, so he's going to get given some number of lollies plus the same some number of lollies. He's given 3 bags of lollies. And it should probably be clear in the question that he's been given 3 bags of lollies. Each bag has the same unknown amount in it. So we've got x plus x plus x plus 2 spare lollies. Okay, x plus x plus x is just 3 multiplied by x. So this can actually be written as 3x plus 2. Okay, and what you'll realize is these are actually what we call like terms. And you'll see why. Because if we're to do the algebra tiles, which is what this second question asks, well, let's do it. Let's create the algebra tiles. We need 3x plus 2. So it's going to look something like, I tidy this. So we need 3 groups of the unknown. So 3x plus 2. So it's going to be like this. You're going to get something like that. So we can draw that below. So x, x, x. And then we've got the extra 2 there. Okay, so these, because they use the same tile, are actually like terms. Those are like terms, and you might have actually noticed these are like terms, 1 and 1, because because they're using the same tile, they're like terms as well. Now, if we really wanted to, we could really step this out. We could say x plus x plus x, plus he gets 2 spare lollies, so plus 1 plus 1. But that would be a really inefficient way to write things. It's a much better to write 3x plus 2. Okay. Okay, and Oompa Loompa says that he can triple the number of lollies that Augustus has. Write an algebraic expression to represent the number of lollies that Augustus now has. The Oompa Loompa comes along and says, all right, I'm going to do 3 multiplied by everything that you've already got. And he's already got 3x plus 2 lollies. Okay, so you've got a 3 multiplied by the whole thing. So this use of brackets here is very, very important. Okay, and generally with algebra, we start to drop the multiplication sign. So it's going to be 3 times 3x plus 2. Okay, Augustus opens the bag and realizes that there are 3 lollies in each bag. How many lollies does Augustus have in total? Okay, well, he realizes that this number here is a 3. So what that means is we're going to make a substitution. So it's going to be 3, okay, 3 groups of, now remember, 3x means 3 multiplied by x. X plus x plus x is 3 times x. So 3 multiplied by x, and he said there's 3 lollies in each bag. So it's going to be 3 multiplied by 3 plus 2. Okay, now we've got to follow BODMAS, and we have to do the brackets first. So 3 times 3 is 9, plus 2 is 11. So 3 bracket 11. Now that means 3 times 11. So that means this is going to be 33. And let me just double check that that's right. So yeah, I think that looks pretty good. He has 33 lollies in total. Excuse me. All right. Wonka gives Veruca Salt the following: 1 bag of lollies with an unknown number of lollies in it, 1 bag of lollies with a different unknown number of lollies in it, and 3 spare lollies. Draw a picture to represent this situation. All right. Now we've got to be a bit more creative with our picture, I would think. So let's say this is 1 bag. And let's draw it. I'm doing my best to draw. I'm not a very good drawer. Okay, so that's the first bag of lollies, and let's say that bag of lollies is maybe a bit bigger than the next bag of lollies. Let's draw the second one a little bit smaller. Went the wrong way. Okay, so you can see the different sizes, so they've got different number of lollies in each bag. That's one way we can draw a picture to represent that there are different lollies, different number of lollies in each bag. Okay, and then there's 3 spare lollies. All right, you're probably sick of me drawing, but I'm going to draw them. Looks like a fish. Just not what I'm trying to draw. Trying to draw lollies. All right, next one is there, bang. Would you believe I had to Google how to draw a bag of how to draw those bags? That's how bad at drawing I am. Anyway, so there's the 3 spare lollies. All right, write an algebraic expression to represent this situation. Define the unknowns that you use. Okay, we're going to say that this bag of lollies here, the unknown number of lollies in it is x. And we're going to say for this one here, the unknown number of lollies is y. We can use any letters we like. And then we've got these 3 spare lollies. Okay. Now we need to draw the algebra tiles. So let's think about what the algebra tiles would look like. So if we go back here, let's tidy that up. So we've got x, all right, plus y. So y has to be a different size tile because they're not like terms. And then the last part was plus, I think, plus 1. So it looks something like that. X plus y plus 1 would be represented like that using algebra tiles. So we go back here. X, y has to be shown to be a different size. X plus y plus 1. Okay, you notice there's actually no like terms in this expression because none of the tiles are the same. So we can't do anything else. We have to leave it as x plus y plus 3. Oh, my bad. Plus 3. There was supposed to be 3 spare lollies. So let me fix it up quickly. So it should be like that. Okay, so it looks something like that. Okay, Veruca opens the bag and realizes there are 4 lollies in the first bag and 7 in the other. So it's just going to be 4 plus 7 plus 3, which is 11 plus 3, which is 14. She has 14 lollies in total. Okay, Wonka gives Mike TV the following: 2 bags of lollies with an unknown number of lollies in it, 3 bags of lollies with a different unknown number of lollies in it, 1 spare lolly. All right, 2 bags of lollies with an unknown number of lollies in it. Let's call that X. So write an algebraic expression. So it's going to be X, but there's 2 of them. So 2 bags, so X plus 3 bags of lollies with a different unknown number. So the different unknown number we can call Y. And there's 3 of them, plus 1 spare lolly. Okay, that's a nightmare to write out, and we can write this a lot more simply by collecting like terms. These are like terms, and these are like terms. So the way we'd write this is, well, X plus X is 2 times X. So we'd write this as 2X. Y plus Y plus Y is 3 groups of Y, so that's 3Y plus 1. So that's how we would write our algebraic expression there. All right, using the algebra tiles. I reckon you get the picture with the algebra tiles, so I'm just going to draw this straight away. X times X. All right, and then we're going to have some Y tiles. They have to be shown to be a different size. I've got 3 of those. And then we've got a single spare lolly. Okay, Mike opens the bag and realizes there are 2 lollies in the first bag and 4 in the others. In the other, how many lollies does Mike have in total? Okay, let's do this the old school way, because probably what happens is we start to think using addition, and then we've got to level up in life and start thinking using multiplication. So this one has 2. So then there's going to be another 2 here. There's going to be 4 here, and then there's going to be 4 here, plus 4 plus 4 plus 1, yeah? So in total, we're going to go 2 plus 2 is 4 plus 12, 16. So what's that in total? 17. Okay, but isn't it better if we can just use multiplication? So we know the expression is 2x plus 3y. So it's 2 multiplied by x, which is 2, plus 3 multiplied by y, which is 4, plus 1. Okay, now we just need to use BODMAS. 2 times 2 is 4, plus 3 times 4 is 12. So we do this, and we do this, and then we add 1. So 4 plus 12 is 16, plus 1 is 17. Okay, so again, we've made a substitution. Once we know what these values are, we substitute them in using multiplication, okay? Because multiplication is repeated addition. It's a large idea that we're trying to sort of wrap our head around with this. Okay, last one. Wonka gives Charlie Bucket, part 5. So Wonka gives Charlie Bucket a bag with an unknown number of lollies in it. He says that if Charlie doesn't give Mr. Slugworth the everlasting gobstopper, sorry, I spelled that wrong. Maybe not. The everlasting gobstopper, he will multiply the number of lollies by the same unknown amount. Write an expression to represent this situation. Okay, so write an expression to represent this. Well, there's some unknown amount, which we're going to call x. All right, now we're going to multiply this by x. And it's going to be tempting, and lots of people are going to write this, 2x. We really need to be super clear. There is a big difference between multiplication and addition. We're now multiplying x times x. Okay, the way we notate this is not necessarily collecting like terms. This is multiplying x times x. And the way we write that is x squared. Very different to 2x. X squared does not equal 2x. Okay, can't stress that enough. Okay, if the number of lollies in the bag is 5 and Charlie does not give Mr. Slugworth everlasting gobstopper, how many lollies will Charlie get? Well, there was 5 in there. And Wonka said that if he doesn't give it to him, he'll multiply that whatever number's in there by the same unknown number. So he's going to multiply it by 5, so he's going to get 25 lollies. So yeah, that's hopefully a nice introduction to how we start to collect like terms when we're using algebra. A classic example is something like this. X plus X gives us 2X. Y plus Y plus Y gives us 3Y. Okay, another example is here. X plus X plus X gives us 3X, three groups of X. I hopefully found that helpful.